Hello, this is John from TC Math Academy. And in this particular video, we are going to graph the rational function. So this right here in algebra is referred to as a rational function. Just remember, in mathematics, when you hear this word rational, you can generally think of fractions. Okay, so for example, the number 2/3, this is a fraction, but it's also a rational number. It's a number that can be expressed as a fraction of two integers. So I don't want to kind of get into these technical details, but in words and descriptions are important in algebra and in mathematics. So when you hear the word rational, you got to say, what does that mean? Well, again, think in terms of fractions. Now, when we have variables involved, we wouldn't refer to this as a fraction. We would refer to this as a rational expression. And this right here is a function. So this would be a rational function. And the numerator and denominator here are polynomials. So kind of get into some extra detail here, but it's important that you understand what type of problem we are dealing with. Now, I'm going to kind of forewarn you, there's going to be a lot of steps here to be able to solve this. So no way you could put your graph into the comment section if you know how to do this. However, what I'd like you to do is to at least give me kind of like the general steps to graph this rational function if you think you could do it. Also, if you want to participate, go ahead and take out a piece of paper, work on this problem. I'm going to show you the sketch of this here in just 1 second. And then, of course, I'm going to go through the full solution. Also, if you need math help with the course you're taking, test prep, or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to it in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Now, one last comment before we see the sketch here. Some of you might be saying, yeah, I know what I'm going to do there, Mr. YouTube Math Man. I'm going to go get my graphing calculator. I'm going to plug all this in, and then I'll get the graph on my graphing calculator. You know what? That's not a bad idea. If you are studying rational functions, you need to know how to use a graphing calculator. In other words, this topic is taught generally at the Algebra 1, and you get into it even more and more detail, like in Algebra 2, College Algebra, Pre-Calculus, and those courses you will need to use a graphing calculator, something like a TI-84, TI-83, et cetera, et cetera. So it's important that you know how to use your graphing calculator as well. But we're not going to use a calculator for this particular problem. We're just going to do this old school with a piece of paper and pencil and some knowledge. But let's go and take a look at the sketch of this rational function. And this is basically what you should have if you did this thing correct. So the graph of this rational function is in yellow. Okay, so this is what we call branches. So you can see the graph is not continuous. I'll talk more about this here in a second. But this would be the graph of this rational function right here, or a sketch of it. Now you can see here I have HA and VA. So what does this mean? Well, this is the horizontal asymptote, and it is the line y equals 1, and then we have a vertical asymptote right here, and it is the line x is equal to 2, and then of course we have these points over here. So these asymptotes are important, a very important part of the sketch or graph of this rational function. So if you got this right all on your own without the aid of a calculator, boy, that's very impressive. Matter of fact, I'm going to give you a nice happy face, and I don't dish out A++s or percentages generally over 100%, but let's go ahead and give you like 130%, an A++, and multiple stars. So you can tell your friends and family and post on your social media that you know how to graph a rational function without the aid of a calculator. That is super awesome. I'm pretty sure a lot of your friends and family will be impressed with that information. Okay, so now let's go ahead and get into the problem. Now, you need to know a pretty good amount of things in order to graph rational functions. Now, I'm just going to give you a general kind of overview here, and we'll talk about the steps here in a second. But if you need like a lot of help in this, you really need to learn this and really practice this. And of course, you are going to need to know how to do this if you're in those classes like College Algebra, Pre-Calculus, Algebra 2, things like that. Check out all those courses. I have them all in my Math Help program. So whatever you're in, you'll see that I have a chapter on rational functions, how to graph them, solve them, etc., etc. Okay, but let's take a look at the general steps here. So the first is the graphs, generally speaking, of rational functions are going to be in branches. In other words, they're not going to be continuous like this. They're going to be something like this, or like the graph we had like that. There's these separations, these non-continuous graphs. This would be a branch of a graph. This would be another branch of a graph. So you want to be thinking in terms of branches. So these branches, like right here, let's go back up to our actual answer, are kind of separated. There's like a buffer zone in between these branches. Now, it all depends whether you, it all depends on what type of rational function you're dealing with. Okay, so not every single rational function will have all types of asymptotes, but those buffer zones are what we call asymptotes. But more than likely, you'll have at least one type of asymptote on your rational function graph. That again, it's all but case by case basis, but you need to understand the concept of asymptotes. Now, asymptotes is a line, okay, so right here, let me kind of just hone in right here. So we can see our horizontal asymptote. What a asymptote is, it's a line where the graph approaches, okay, you can see this line, or the graph right here, this branch of it is approaching this line y equals 1, but it's never going to cross it or touch it. Okay, it's going to get infinitely close to it, but then it's never going to cross over it. So it's like a kind of it's kind of guiding the graph it's like a buffer zone, okay? And it's like, okay, the graph is going to get closer, 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 but it's never going to cross over it, okay? So when you graph your rational functions, you kind of want to show that behavior. All right, so hopefully I explained that without it being too confusing, but that is what an asymptote is, and you can have a vertical asymptote, in other words, a line in this direction, okay, that the graph is approaching. You could have horizontal asymptotes. In this particular problem, we have both of these. And you can also have sloped asymptote as well. This is a little bit more involved. We're not going to get into this in this particular problem. But again, if you're studying this in other courses, you'll get into all of this stuff. So this is a pretty simple problem in terms of rational functions. Certainly there's much more challenging ones, but we're going to be covering the general idea here. All right, so the first thing again is that we're kind of expecting a graph that has some sort of branches into it. We're expecting that we're going to have at least maybe one or more types of asymptotes on our graph. And then the next thing is we need to construct a table of value and plot points. Okay, so we need to, in order to get the actual behavior of a graph, it's a good idea for us to plot some points, and the way you plot those points or get those points is use a table of values. So this is kind of the general strategy in order to graph rational functions without the aid of a calculator. Okay, so with all that stated, let's go ahead and get into step one. And step one is we want to find the asymptotes. Okay, so I'm going to kind of put aside slope or angled asymptotes for this particular problem. That's for a little more challenging problems, but we are going to be taking a look at the two types of asymptotes that are in this particular the graph of this particular rational function, and namely, this is going to be vertical asymptotes and horizontal asymptotes. Okay, so let's talk about how to find the vertical asymptotes first. So the graph of this rational function right here has a vertical asymptote at x equals 2. So if I told you to graph x equals 2 on a lovely xy plane here, let's review this. So many people get these basic questions wrong in algebra, like, oh, x equals 2, that's a line going this way. Wrong. It is a vertical line. Okay, so here is 2, and you're not going to draw a full solid line that goes through 2. Okay, what you're going to do is just do a dotted line like this, dashed line on your graph like so. That indicates that that is an asymptote. It's not part of the actual graph of the function. Okay, so this rational function has a vertical asymptote, and this line here we would describe as x equals 2. Okay, now let's talk about how we get that. Basically, this is the kind of formula to find vertical asymptotes. So here we have a rational function. We kind of generally describe it as f of x is equal to p of x and q of x, where p of x and q of x are polynomial functions. What we're going to do is find the roots of q of x. That's just kind of all this like fancy language that basically states that, hey, take the denominator, okay, whatever this expression is here in the denominator, this polynomial, set it equal to 0 and solve. That's what that means, okay? So to find vertical asymptotes, all we need to do is take the denominator, set it equal to 0, and solve. So here we'll take x minus 2. We set it equal to 0, and we solve for x. We got x is equal to 2. It is as simple as that. Now, you can have more than one vertical asymptote, okay? It's quite common. Matter of fact, if this was x squared minus 2, what would I have? I would have x equals positive negative square root of 2, right? So you can certainly have more than just one vertical asymptote, more than one horizontal asymptote and slope asymptotes. Okay. All right, so that's basically pretty much it for the vertical asymptotes. Let's move on to horizontal asymptotes. Okay, so the horizontal asymptote for this particular problem was y equals 1. If you recall, I had that little line like this, a little dashed line. A horizontal line is a y equals line, so this is y equals 1. That will be on our graph, so that is the horizontal asymptote. So let's talk about this now, and there's basically 3 cases when we're dealing with a rational function. Let's talk about the first case here. So here is our general rational function. Again, we have p of x and q of x. These are polynomials. So let's talk about the case where p of x, the numerator, is greater than the denominator. What we're talking about here is the degree. Now, I don't have the full notes in here just because I don't want to kind of put too much, into the video to make it too confusing. So I'm just going to explain it. So basically, what this is saying is this: if the power of the numerator, okay, is greater than the power of the denominator, we can see that here in this example, x cubed plus x over x squared. Well, this means that there are no horizontal asymptotes. Now, how you find sloped asymptotes, that's a different deal. Again, we're going to table that for this particular video. But anyways, so in this situation, the degree or the power, if the degree or power is higher in the numerator than it is in the denominator, this rational function would not, right here, have horizontal asymptotes. Okay, so let's talk about the reverse. Okay, let's talk about when the denominator has a higher power than the numerator. Something like this, x squared minus 4, that has a higher power than 5x, which is in the numerator. So in this case, q of x, that denominator polynomial, is greater than the numerator. In that case, you have a horizontal asymptote of y equals 0. Okay, that's always the case. So y equals 0 is what? Well, this would be simply the x-axis. Okay, but it is important that you do label your asymptotes. So your teacher will be saying, be looking for you to be like, oh, this function, in this particular case right here, would have a horizontal asymptote y equals 0, or the x-axis is acting as an asymptote. Okay, now let's talk about the last case, which is relevant in our problem. What happens if the degree of the numerator polynomial, i.e. the powers, are the same? So something like this, we have x squared, the highest power, right? 8x squared minus 2x, and 16x squared plus 1. Here you have the highest powers, right? Or the highest powers are the same degree. So how do we figure out what the horizontal asymptote is? Basically, what you're going to do is you're going to take the leading coefficients and construct a fraction. So it's going to be y equals the leading coefficient of this term and the leading coefficient of this leading term down here. So this would be what, 8 over 16 or 1/2. So in this case here, the line equals 1/2. The horizontal line, y equals 1/2, would be an asymptote for this respective graph. Okay, so again, a lot to cover, and we haven't even gone into sloped asymptotes, but this is all we need for this particular problem. So remember, we already figured out what our vertical asymptote was. It was 2, because we set that denominator equal to 2. So now looking at this problem, what do we have going on here? Well, this is a situation where both the numerator and denominator polynomials are at the same power, same degree. So what we're going to do is construct a fraction with the leading coefficient. So there's a 1 here and a 1 here. So this is going to be y equals 1 over 1, or 1. So y equals 1 is the horizontal asymptote. All right, so hopefully this all makes sense. And if it doesn't make sense, don't be, like I stated in the beginning, don't be overwhelmed. Okay, even if you are overwhelmed, try to be just kind of like take your time, be like, all right, I'm going to have to review this more slowly, and I'm going to strongly suggest that you kind of check out one of those courses that I mentioned and get some formal instruction notes, and then kind of, you need a lot of practice problems for this stuff as well. But let's go ahead and now get into step two. So step two is, let's just go ahead and plot those vertical and horizontal asymptotes on our graph. Okay, so here is our lovely XY graph. Here is our horizontal and vertical asymptotes. Now here's the deal. We just don't know the behavior of this graph. We're thinking in branches, right? These are borders that the graph can't cross. So it could maybe be something like this. It could be something like that. That's one possibility. Or maybe this or this. We just don't know, right? We don't know yet what the branches will look like, but there is a nice little way to figure this out. And the way to figure out any graph in algebra or any more advanced mathematics is you can always construct a table of values, and that's what we're going to do here. So good old-fashioned XY table of values, and we're just simply going to make up some points. So -6, -2, 0, 1, 3, and 6. So these would be points that would span across the x-axis, right? Like -6 right here. Here's 0. What else? What other points do I have here? -2, 1, and 3. So here would be like -2. Here's 1. Here would be like 3. So what you want to do is select some x points. Okay, it doesn't make a difference which ones. Just get some good, nice, easy points that kind of span across these various asymptotes. And once you have those x points, what we're going to do is plug in these x points into the function. Now remember, basic function concepts, f of x is the same thing as y. And what we want here, we're going to plug in these x values right here. And we're going to plug in these x's into all of this. We're going to do all the number crunching. And when we get done, we're going to find f of x for that particular value, which is y. And this combination, these combinations right here, like -6, 1/4, this is the point ordered pair, -6, 1/4. In other words, this is a coordinate that we can plot. Okay, so these points are in fact on the function. Okay, so now this is where really we're going to be kind of playing connect the dots. So we're going to take all these points, plug them into the x's here, and then you'll get these respective y's. I'm going to spare you all that number crunching, but if you want to kind of challenge yourself, you can pause video and see if you can complete this table. Okay, given these values here. And again, it doesn't have to be these values, right? It could be other values, but just use nice, easy integers to work with. But what you need is some points, okay? So we can kind of start seeing the behavior of this graph. All right, so now that we have our table, and all of these, again, are x, y points, let's go ahead and plot them, and then we're going to graph the function. So here, we'll plot these points, and this is just a really rough sketch. So you want to be as accurate as possible. Certainly, it's always better to use graphing paper if you have it. So you would plot these points, these ones here that we just got on the table, or from the table, our table of values, and then we're going to try to draw nice little branches through those points that show the behavior the behavior of the graph and the asymptotes. Now it's what we call asymptotic behavior. Okay, so in other words, you want to show that branch is approaching but not going to cross through the asymptote. So it doesn't have to be perfect, just has to be readable. Of course, you want to be as neat as possible. This effectively would be the graph of this particular rational function, and you do want to label your asymptotes as well. Okay, so as I promised, there was a lot going on here. And in terms of graphing rational functions, this right here would be on a scale of 1 to 10, maybe like a level 3. This is not that challenging of a problem. And a lot of you might be saying, what are you talking about? Not that challenging? You mean there's going to be a lot harder problems? Yes, but you can handle it, okay? You can handle this and much, much more. What you need to do is start from the beginning, okay? And if there's anything here you don't understand, just make yourself a nice little kind of shopping list. I need this, I need that, I need to figure this out, and then you go to the math store, which is effectively one of my courses and you just start working on this. Oh, now I understand that. Now I understand this. Now I understand that. If you know you don't understand something and if you don't address it, it's going to come back to haunt you over and over in terms of mathematics. So it's always better just to learn what you got to learn and then, move on with success. Okay, so again, hopefully this video helped you out. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.